enclosed by the graph of f of x equals square root of cosine x, the graph of g of x equals e to the power of x, and the vertical line x equals pi over 2 as shown in the figure above. Right, but do not evaluate the integral expression that gives the area of r.
Okay, so let's analyze everything. So we know we have our 0, and we know this guy right here is going to be at pi over 2. Now, just by looking at this, is the top graph f of x or g of x? What do you think? That's the exponential. Exponential is part of what? The top one, right? So I'm going to highlight this guy over here and even circle it just because. And then I'm going to highlight the bottom one. It's going to be our cosine, or square root, I mean. And I think I'm also going to write out g of x over here and f of x over here. You don't have to, but I think it's going to be helpful. It says write but do not evaluate. That's going to happen on part C as well. And we want to find the area of region R. So if I were to create this vertical piece, it's going to scan left to right. Is that with respect to x or with respect to y? When I'm scanning. Scanning left to right is x. Very good. So if you want to go to right with respect to x, although it doesn't really matter because the only way we can do this is top minus the bottom. So the area formula, so since I'm scanning from left to right, my lower number is 0 and upper number is what? Pi over what? 2. And it's going to be top minus bottom. So top is my g of x minus f of x dx. Now, just in case a problem like this could be on number 1 and 2, which is a calculator portion, keep in mind having parentheses is always a good idea after the integral and before the d of x. So here's our point system. Having your upper and lower bound is going to give you 1 point. And then the whole integral with dx is going to give you another point. Isn't that easy? 2 points right there? You can't miss it, okay? And what's nice about g of x and f of x, since they gave us the function on here, you may leave it as g of x and f of x. You don't have to plug in square root of cosine of x, and you don't have to plug in e to the x. Y'all good? Okay. Now let's go to part C. On part C, it's going to ask us to find the other integral. Andrew, let's read part C, please.
Region R is the base of a solid whose cross sections perpendicular to the x-axis are semicircles with diameters on the xy plane. Write but do not evaluate an integral expression that gives the volume of this solid.
Okay, perpendicular to the x-axis is still with respect to x. That did not change. The semicircle is the main key here. So if you look at the formula with the semicircle, which constant am I going to kick outside of the integral? Pi over 8. So I'm going to write, we're looking for a volume, right? Volume, okay. So our volume is pi over 8. The integral, we're still scanning from left to right. My lower bound was 0, upper bound was pi over 2. And the only difference on this one is going to be top minus the bottom, but then we're going to take our formula and square it. That's the only difference. So g of x minus f of x, and all squared dx, and that's it. So let's look at our point system. Knowing to kick out the constant, that's going to give you 1 point. And then the whole integral with pi over 2 as your upper and 0 as your lower bound is going to give you 2 points. Again, is this a freebie basically? So that alone already is 5 points, okay? So then let's go on to part B then. On part B, Ian, go ahead and read.
Find the volume of the solid generated when R is revolving around the x-axis.
Okay, around the x-axis. Let's kind of look at the picture then. I'm going to look at the visual here, and I'll redraw it. So if it's going around the x-axis, what's going to happen is I'm going to create another figure. Let's see if I could change my color. So if I redraw this, would you agree it's going to reflect on the bottom over here? Something like, and this might pass my graph, which is fine. Something like this. Do y'all see that? And this should be a little bit longer. So if I cut through and dissect, I'm going to create a big circle here, little circle here with our center. So on my big circle, we have g of x to center 0, and little circle is f of x is 0. Because it's kind of all cramped together, let's put that as a picture by itself on part B. So on part B, I want you to give me a large oval. Let's It's really a part of a circle. The top was g of x. What was the middle at?
F of x. Oh,
0. And then when I draw the inner circle, we have, that's going to be our f of x. In this formula, it's going to be part of our pi, and it was big R squared minus little r squared. So applying that part is easy, but integrating is going to take some work. So let's actually do some part of it. So we have, here's my big one. So let's write out our volume. We're kicking out the pi, integral from 0 to pi over 2. And then we have g of x minus 0. And I'm going to write out the 0 piece just because. And it says all squared, wrap it up, all squared. And then we have minus, the inner part is going to be, if I highlight, it is f of x minus 0. So we have f of x minus 0, it's going to be all squared, and dx. And just because it's a good habit to put parentheses around the whole thing, go for it. But if you don't, I don't think they're going to take off points for it because you have everything you need. Now let's plug in what I know. What's going to go in place of g of x? Look at the front.
E to the x.
Good, e to the x. So I'm going to put in e to the x. And it's all squared. I'm going to put all squared. Any questions on that piece? Okay. Minus, what was on f of x? Square root of cosine of x. And again, all squared. This is kind of nice because that's going to cancel out. And then we have dx. And we are integrating the whole thing. I want to worry about integrating, actually, let's rewrite this out. We have pi, 0 to pi over 2. It's all about repeating. E to the 2x minus. Would y'all agree these two are going to cancel out, the square and the radical? So we have just cosine of x. Cosine of x dx. And let's wrap it up. So let's worry about integral of e to the 2x. This I'm going to do on the side. We're going to let u equal the power. So u is equal to 2x. du is equal to x dx. Not x, 2 dx. I know a lot of you guys should pick up your pencil and start writing from here, right? Is she gone? Right with me? So we have, and then when I do my direct substitution, I know I have my du. And dx du, we have, let's go ahead and kick out the 1/2. Because I want dx by itself. Then we have du is equal to dx. And then our direct substitution. We have our 1/2 that's kicked out, and integral of e to the u du. You guys okay with that so far? Okay? The integral of e to the u is itself. So we know we have 1/2. E to the, instead of u, I'm going to put 2x. So now let's go ahead and plug it in here. We have pi. And then I'm going to open my parentheses. We integrated e to the 2x. It was 1/2 e to the power of 2x. What was the integral of cosine? Was it positive or negative sign? Ooh. Just cosine alone is sine, and I already have that minus sign, so I'm going to leave that alone. And then I'm going to wrap this up and say, now let's plug in pi over 2 and then the 0. From here, it's going to be pretty much the algebra piece. Leave the pi alone. If you want to draw the arrow over here, because it looks kind of cramped, go for it. The first thing I'm going to do is plug in pi over 2. So we have 1/2 e to the, if I plug in pi over 2, would you agree the 2's cancel? Yeah? Pi? And then now I'm going to plug in pi over 2 into my sine. Sine of pi over 2. Minus. Now I need to plug in the zeros. When I plug in the zeros, I'm going to start putting in parentheses. What is e to the power of 0? 1. And 1 times 1/2 is simply 1/2. Now let's see what would happen when I plug in sine of 0. If I plug in sine of 0, add 0 over here, that is 1 comma 0. Is my sign 1 or 0? It is 0. Do I need to write the 0 on there? Absolutely not. So now let's further simplify. I want you to put a dot at top. Top has the value of 0 comma 1. So all of sine of pi over 2 is how many? 1. So I'm gonna write on here half of e to the pi minus 1 minus 1/2. And as long as everything has been evaluated, as in what sine of pi over 2, what is sine of 0, you don't have to go on any further. So at this point, let's see where our 4 points are going to be divided into. Having, let's see where I have it. All this right here. And plugging in the value, that's going to give you 1 point. And then integrating all the way through for both the sine or cosine and the e to the x, that's going to give you 2 points, because technically you integrated not just e to the x, but also sine or the cosine. And our final answer right here is going to give you 1 point. So let's make sure we tally. So we got 4 over here, 5, 6, 7, and then front was 8, 9. Yep. So let's go ahead and write off to the side over here. I want you to put how many out of 9 was your raw, how many out of 9 was your potential.